I'm Jessica, and I'm going to be discussing with you magneticity at different temperatures. So we're going to do a little experiment, and we're going to explore how different temperatures affect the magneticity of magnets. So what is the effect on the temperature of magnets measured in degrees Fahrenheit? We're going to use this thermometer here of a magnet, and the magneticity on how many paper clips it will attract. So in other words, if it's at room temperature or if it's in a freezer, what is the difference in the strength of the magnet? I predict that the magnets are not going to be affected by temperature at all. So again, this experiment is about magnetic attraction and how different temperatures affect magneticity. A couple of the key vocabulary words to remember during this experiment is going to be measuring temperature. And by measuring temperature, we're going to be measuring the hotness or coldness expressed in terms of degrees Fahrenheit using the thermometer. Magneticity is a big word, and that's just a big word that means is the power to attract. And I'm going to skip over to attraction, which is a force under the influence of which objects tend to move toward each other. So attraction is a force between two objects that move toward each other. And again, I'll do it here. I can just let go of that magnet and they are forced to go toward each other because of magneticity and attraction. Magnetic materials are items made up of iron, cobalt, nickel, and steel. And so our paper clips here are actually made up of steel wire, and that is a magnetic material. And to affect is to change cause a change in something. Measuring temperature in degrees Fahrenheit is going to allow us to compare the attraction of magnets at different temperatures. Temperature can be measured by holding the thermometer to the magnet, and magnets are attracted to magnetic materials such as the paper clips. So magnets and magneticity work without having to make something move. You know, typically if I just drop the magnet, it will fall. But if I'm holding it close to another magnet, magneticity forces it together. And so we're going to explore that and how that works with paper clips. Without having to touch paper clips, they're going to go toward the magnet. Understanding the key terms that we just went over is extremely helpful when completing this experiment, because we're going to be working directly with comparing the temperatures of the magnets and the change in attraction due to the change in temperature. Knowing that a change in attraction is a change in magneticity is required knowledge when reading through this experiment. So the manipulated variable is going to be the actual temperature of the magnets. So when I did the experiment, I had some magnets already in the freezer, I had some in the refrigerator, and then I had some just sitting out like I do here at room temperature. The responding variable is the number of paper clips that are going to be attracted to the magnet. So as we complete the experiment, how many paper clips are going to be attracted to the magnet at different temperatures. So how many are attracted to the room temperature magnet, how many are attracted to the freezer magnets, and how many are attracted to the refrigeration magnets. The constant things that are not changing is going to be the exposure of the same number of paper clips. So the number of paper clips right here in this pile is 99. I bought a 100 pack, one of them was broken. I even counted them all out to make sure that there were 99, and there are 99. So every time a magnet is used, we're going to put it in that same pile of 99 so that each magnet has the same chance to pick up as many paper clips as it can. Another one of the constants is going to be the size of the magnet used. So as you can see here, every single one of these magnets are the same size. The ones in the refrigerator and the ones in the freezer are also the same size. And then the size of the paper clips used is also the same. So every single one of these paper clips might be different colors, but they are the same size. Other materials that are going to be needed are the thermometer. We've got the magnets, paper clips, the freezer and the refrigerator for change in temperature, and then a non-magnetic surface. And I added that as a material because it is extremely important to make sure that you're not having any kind of resistance when it comes to picking up the paper clips because you're working on a magnetic surface. So for example, this TV stand here is slightly magnetic, so there's a little bit of force there. And then if I try to pick up a paper clip that's on it, because of the force that's there, yes, I can pick up the paper clip because the magnet has more force than the TV stand, but there might be some resistance working against us there with another magnet, and I can show you that force, or if you had a couple of magnets, you could try out the force as well. So if you take the north and south ends and try to put them together, you can see that no matter how hard I try to put them together, they are still opposing each other, or resisting each other. And so you don't want to use a magnetic surface because you don't want to have any resistance. So the first thing that you're going to do when you actually complete the experiment is take apart one of the magnets from your stack of 10. I also have them in stacks of 10 like this in the freezer and refrigerator. That's another way that they're presented is going to be the same. When you grab one from the stack, and I'll do it here as well, I like to grab it with my left hand because I write with my right hand and we're going to be recording this data. So I grab one from the stack and I don't touch the actual surface that I'm going to record the temperature of. Turn the thermometer on and place it on the magnet. And I'm not touching it because I don't want my hands or the temperature of my hands to change the temperature of the magnet in any way. So right now it's reading 73.4. And so I'll set that down. The second thing I do is going to record the temperature. And then I'm going to hold the magnet above the pile of 99 paper clips. I'm going to bring the magnet to the pile once, and then I'm going to lift and move it away. Now I'm going to take all of the paper clips off of the magnet, and I'm going to count the paper clips. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, so there's 21 here. So now that I've counted that, I want to record that in the data chart, and then return these paper clips to the pile of 99. So again, the next magnet can have the same chance as the previous magnet to collect as many as it can. So once you use the magnet, you want to make sure that goes into a different pile. You're not putting it back in the same pile because you have 10 different magnets. While they're the same, you want to make sure you measure each individual magnet's temperature, and then you also want to not use the same magnet twice. So one that you've used, put it in a different pile, and then when you're done with all 10 magnets, you'll have all of your data. You can move on to the freezer magnets or the refrigerator magnets. And again, you repeat all of the steps until you've used up all 30 magnets. I recorded the data here for you. If you choose to do the experiment, then you can do it as well. But on average, room temperature is about 76.18 degrees here at my house. And the number of paper clips that's attracted is about 24.8, so you can round that up. But for this, we're going to leave it at 24.8. Refrigerator temperature, the average temperature in my refrigerator was 51.19, and the average number of paper clips it attracted was 25.9. And for the freezer, the average temperature of the freezer was 26.73, and the number of paper clips attracted was 26.1. So you can see a trend as it's getting cooler, it's actually increasing the number of paper clips that it can attract. So here's some extra data here. The median, mode, and range. Always good to calculate that in any experiment that you do. This graph shows you that the temperature of the magnets, as it increases, the number of paper clips decreases. So that's a good visual representation. Again, at the average temperature, room temperature is 76.18. On average, that held 24 paper clips. At 51.19 in the refrigerator, that held 25.9. And the average temperature in the freezer of 26.73 held 26.1 paper clips. In conclusion, measuring temperature in degrees Fahrenheit, we were able to compare attraction of magnets at different temperatures. Magnets attracted the paper clips because of their magneticity. The levels of magneticity changed as the temperatures changed. We actually found a trend that showed magneticity was stronger or attracted more paper clips as the temperature dropped. That same trend showed that the magneticity was weaker or attracted less paper clips as the temperature rose. I believe this occurred because the way that the molecules move faster at higher temperatures are more concentrated. I believe this occurred because of the way that molecules move. So at higher temperatures, molecules move faster, and at lower temperatures, molecules move slower. So at colder temperatures, there's a more concentrated or a slower movement in molecules. And so that concentration allowed for the magnets to become stronger or more concentrated. So in the real world, you actually use magnets almost every day in your life. When you open the refrigerator or the freezer door, they are held by magnets. So when you're opening them, that is a magnet in action. Credit cards are also used. There's on the back a mag strip. That's actually a magnetic strip. And then there's also your phones, earbuds, and some kids' toys. Very common things that you see every day all have magnets used inside them. Another very important use for magnets is going to be in the medical field. A lot of their machines that they use are built with magnets. So for example, the MRI machine that you see here has powerful magnets that help see inside of the body. So it helps create the images that doctors see to diagnose what's wrong with the patients. So after this experiment, I think I can understand why hospitals might be kept so cold. Throughout this experiment, there was quite a few days that I worked on it. So on October 6th, it seems like so long ago, I researched the topics and emailed for approval. On October 7th, I got the okay, posted to the discussion board, ordered magnets and a thermometer from Amazon, so I started ordering the materials. The following day, I received the order and I began to read through all of the instructions online. On November 6th, now about a month later, I opened up the template and started to work on the science experiment template. On the 7th, I went to the store to buy paper clips because I was going to start the assignment that day and realized I can't do this without paper clips, so I had to go buy some. And I also put magnets in the freezer that day and the refrigerator. No, I didn't. I just put them in the freezer. On the November 18th, I completed the room temperature and freezer experiment and decided to do the refrigerator because I wasn't originally going to do the refrigerator. So that is when I put them in the refrigerator. And I wanted to give them a couple days, as I did give the freezer magnets a couple days as well to get to a good temperature. And then on the 20th, I completed the experiment with refrigerated magnets and inputted all of the data into the data chart. And November 21st, I finalized all of the details. Thank you.